The James Webb Space Telescope often revisits scenes imaged by its predecessor, the Hubble telescope, and so it is with today's image. Hubble recorded it in visible light and the smallest wavelengths of the infrared spectrum, while Webb sees much further out into the larger infrared wavelengths. Webb's picture reveals features and structures unseen by the Hubble. This week, NASA released two images taken by the Webb telescope of the Ring Nebula, a huge glowing space cloud, the dying gasp of a red giant star. This is the first image, taken in the infrared closer to the visible. Unlike the image of Arundel, the subject of this photograph is not subtle. The Ring Nebula is big, literally and apparently. It's about 6 times too dim to see with the naked eye, but not too hard to find with a small telescope, making it a popular target for amateur astronomers. Despite appearing as large in our night sky as Jupiter, it's more than 2,000 light-years away. In the center of a light-year-wide glowing ring, the remnant of the star remains, not clearly revealed in this image. The remnant is about 60% as massive as the Sun, but the mass has gravitationally collapsed down to a fraction of the Sun's size. Its surface temperature is about 125,000 Kelvin, more than 200,000 degrees Fahrenheit. The star at the heart of the nebula evolved, like our own Sun, through the stellar life cycle. Such a star eventually burns through its supply of hydrogen and grows into a red giant with a dense core and a distended atmosphere. This allows it to fuse 3 helium atoms with 4 nucleons each into 1 carbon with 12. After a billion years or so, the helium is all turned to carbon. A large star can continue burning, fusing the carbon along with oxygen into heavier atoms, but a medium-sized star cannot. At this point, the hot, dense core of the medium-sized star expels the gas in its atmosphere. The Ring Nebula star began this process a few thousand years ago. The hot star remnant is furiously emitting ultraviolet light, wavelengths smaller and more energetic than visible light, into the expanding gas cloud surrounding it. The gas absorbs this UV light, which knocks electrons out of its atoms. The absorbed energy of the UV rays trickles back out of these ionized gas atoms as emission at different wavelengths. The gas emits or glows with certain colors. To the human eye, the external ring is visible in pink, with a pale blue inscribed ring and a faint darker blue center. Objects like this were called planetary nebulae by early astronomers because they appear large and round, often blue or red, but faint like a ghostly planet. Webb's image assigns visible colors to a wide range of invisible infrared wavelengths. The portion of the center appearing blue is mostly helium, the aqua color is hydrogen and oxygen, and the pink is sulfur and nitrogen. You can also see a field of small clumps clustered in the gas. These globules are groups of hydrocarbon molecules that emit larger wavelength light, where Webb's huge mirrors and infrared cameras can see them. The appearance of separated rings of material in the image could be caused by a second star orbiting the fading giant and preventing the blown-off gas from forming an expanding sphere. This is Webb's second image, taken at even larger infrared wavelengths and colored differently. It shows more rings further out from the center. It also clearly shows lines streaming out from the center. Now, scientists will offer possible explanations, but as of yet, these remain a mystery. And that's what the Webb telescope saw this week. I hope you found this video informative. Please stay tuned for more upcoming videos on interesting aspects of space, science, and technology. Have a good one.